In this video, we're going to talk about how to solve number 34 and 35. This particular problem is asking about the time that it will take to fall for the object from point A to point B, but in the second case, if the bullet doesn't stick in the thing, we're going from A prime to B prime. Well, the nice thing about each of these pictures is we are at height h in both of them. And if you remember, when we talk about projectile motion, we always make a horizontal and vertical chart, like so. All right, now you realize on the horizontal side, the initial velocity for one of them will be VA, for the other it will be VA prime. Okay, so A or A prime, either one, don't have to really worry about that very much. But we also know that V final will be the same thing. All right, so those will be equal. And we know the acceleration will be 0. Just a quick review of projectile motion. But on the vertical side, remember this is a half parabola starting at the top of the parabola. So initial velocity here will be 0. And that is true in both cases because they're both starting off at a horizontal. The acceleration for both will be negative g because it's falling under the influence of gravity. My starting height, x initial, will be h for both of them. My final height for both of them will be 0. And this means that since the vertical is the same on all pieces for both, I can get an expression for time using the equation x final minus x initial equals v naught t plus 1/2 a t squared. Now I'm going to cancel out. I know initial velocity is 0. I also know final height is 0. So if I put in the letters that we have, I'm going to get negative h equals 1/2 negative g times time squared. And the time, if we solve, will be equal to the square root of 2h over g. The negatives will cancel. And this will end up being the same for both because the initial speed will not affect at all the time to fall that's only in the vertical. Same for both. So when we go to make a ratio of time AB divided by time over A prime B prime, I'm going to get the square root of 2h over g divided by, scroll down a little bit, the square root of 2h over g, and I will get 1. So that would be the answer for number 34. That's how we figured out that the ratio is 1. Now 35 is a little bit more mess because now I actually need to get the equations for the velocity at A and the velocity at A prime. All right, and the velocity at A is not too bad. The velocity at A prime is a bit of a mess, so I will warn you. That's where the video is going to get long. All right, so let's do, the first one is called the inelastic. And our goal is to find velocity at A. Okay, so let me draw some pictures. In the beginning, we have a bullet of mass 1 with a starting velocity of vi is what they called it. All right, mass 2 is sitting at rest. v2 initial equals 0. And those are the before pictures. The after picture, of course, looks like the bullet stuck inside the mass. So this is going to be mass 1 plus mass 2 because there's a total adding it together. And the velocity it has here that we were calling VA, that was our goal for V final. So the equation that we have developed here is mass 1 VI plus 0 essentially is going to equal mass 1 plus mass 2 times VA. So I can see my expression for VA is going to be mass 1 VI over mass 1 plus mass 2. I'll put a box around that so when we get to the end we can find all of that. Thankfully they don't ask me how far the thing went because then I would need to put that back in the horizontal vertical chart and go through that. All right, so let me draw a line here, and we will look at the elastic case. Okay, remember, as I write this, what's special about elastic collisions is that they have kinetic energy conserved as well. Hey. So the picture for this one, again, I have the bullet, mass 1, going at speed vi. Here I have mass 2, but velocity 2 initial is 0. Okay, afterwards, I'm going to have the bullet is somehow going to bounce back. I'm going to call this velocity, I'll call it, yeah, velocity 1 final. And here, mass 2, we, in the thing they call it VA prime, okay, for a different speed. Okay, so let's start with momentum. I've got two equations that I've got to work with here, both the momentum and the kinetic energy. All right, so I'm going to have mass 1 VI plus 0 again is going to equal, I forgot to label mass 1 here. I don't think it matters much. Mass 1 V1 final plus mass 2 VA prime. Now, my goal eventually will be to eliminate V1 final, so I'm going to solve for it right now so I can use it to set things equal together. So this will be mass 1 VI minus mass 2 VA prime, all divided by mass 1, will equal V1 final. Okay, now for the kinetic energy equation, we know, since kinetic energy is conserved, I'll have 1/2 mass 1 VI squared plus 0 again is going to equal 1/2 mass 1 V1 final squared plus 1/2 mass 2 VA prime squared. All right, now the first things I'm going to do, I'm going to get rid of all the 1/2s, cancel them all out, and when I have that, I am just left with what's there. But I want to substitute V1 final into it, so this is going to get big and messy real quick. Mass 1 VI squared is going to equal mass 1 times the quantity mass 1 VI minus mass 2 VA prime all over mass 1, and don't forget all of that has to be squared, plus mass 2 VA prime squared. All right, now the beauty of that mess, let me scroll back up, sorry, we do need to expand all of that, meaning squaring it. We've got a nice foil going on here, so this is going to get big. So we got mass 1 VI squared equals mass 1. In the numerator, we're going to have mass 1 squared VI squared minus 2 mass 1 mass 2 VI VA prime plus mass 2 squared VA prime squared all over mass 1 squared and quantity plus mass 2 VA prime squared. Alrighty, the first thing I notice is that this mass 1 will cancel one of these, and I'm going to move the bottom mass 1, multiply everything by it, so it'll add a mass 1 on the left side over here, and it'll add a mass 1 over with the M2 over here. So I just don't like denominators, so this will become mass 1 squared VI squared, and we have all the parentheses left, mass 1 squared VI squared minus 2 mass 1 mass 2 VI oops, that's supposed to be VA prime, VA prime plus mass 2 squared plus VA prime squared Plus, now the last term, don't forget to add that mass 1 on there. Mass 1, mass 2, VA prime squared. Okay, now nicely, notice this mass 1 squared VI squared repeats on both sides, so we can cancel those. Now I'm left 0. I'm going to be left with a 0 on this side, essentially. So since I have a 0 here equal to all this stuff, if I can find anything that matches in all this other stuff, I just noticed a plus where it's not supposed to be. This is supposed to be a multiply in there. So let me get rid of that plus there. All right. So anything that's in all these other terms that is the same everywhere, we can also cancel all of those. So the first thing I notice, all of them have a mass 2. So I'm going to drop out one mass 2 out of all of them. Okay. I also notice every one of them has a VA prime. So let's get rid of a VA prime. One of those, one of those, one of those. Okay, so now I'm left with, what do I have left? Negative 2 mass 1 VI plus mass 2 VA prime plus mass 1 VA prime. I'll scroll some more. All right, I'm going to move the negative 2 over, so it's positive 2 mass 1 VI, and I'm going to factor out a VA prime out of both sides. You'll see I'm left with mass 1 plus mass 2. And if I solve for VA prime, I'm going to have 2 mass 1 VI divided by mass 1 plus mass 2. All right, and so now I finally have an expression for VA. But the goal of the problem, now that we have those, was to determine a ratio of VA over VA prime. So let me, whoop, gotta love smartboards. All right, let me try a new line here. Okay, extend page. Okay, so VA over VA prime. Now, you have to scroll up and see VA again, but it ended up being mass 1 over V, or times VI divided by M1 plus M2. And VA prime ended up being 2 mass 1, VI, all over mass 1 plus mass 2. And now you can see all kinds of stuff cancels, those cancel, the mass 1s and mass 2s cancel, and all we're left with is 1/2.